All right, we're going to do the at-home Wednesday, Thursday 3.2. This is towards the end of the book, or into this section. We're still doing logarithms, and we're going to start natural logs today. And we're doing 41 to 55. If you look on Friday, you're going to have a quiz on 3.1, 3.2 that's on Canvas for you to take. So I put up here in the corner a couple of the natural log deals from the book, and we're going to use one of those, which did not come in very well, but we're going to use this one, actually this one right here, which basically says that a natural log and E are inverses, which is true. E is Euler's number, which deals with nature, and natural log is the opposite or the inverse operation of E. They cancel each other out, and I'll show you what I mean when I get down here to these last two. So this problem right here says that we are supposed to find the domain. We're supposed to get the x-intercepts and vertical asymptotes, if they occur, of the logarithmic functions, and sketch the graph. Well, what I want to do with this is I'm going to write this in exponential form, and I'm going to use that same thing I've used on the last two videos, and that is base stays base, and the other two play switcheroo. This 6 is the base, which makes 6 the base and the exponent. This y becomes the exponent, and this x goes to the other side. And I'm going to do a t-chart. Now, when you do a t-chart, when you flip-flop the x and the y, and you're going to plug numbers into y. So maybe I'll plug a -2 in, -1 in, a 0 in, a 1 in, and a 2 in. Now I'm plugging these in for y. So over here, that's going to be, I'm going to move it over here, 6 to the -2 power. Now we talked about this in the last couple of videos. To make a negative exponent positive, you must move it to the bottom. So this would be 1/36, which is not very much above the x-axis. So I'm going to graph this thing. And I hope you remember what a log looks like. We're going to see what it looks like here in a minute. So if I go to, if this is 136 is really close right here. We're down here at -2. So that point is going to be really close to the y-axis. And if I plug -1 in, that'd be 6 to the -1, which would be 1/6. So if I get a 1/6, which is just a tiny bit over, that's going to be a -1. And then if I type in 0, anything to the 0 power is 1. So that means this is going to go through this point right here. And so this is 1. I'm going to plug 1 in. So 6 to the first is 6. And 6 to the second is 36. So way over here. Yeah, 1, 0, 6, 1. So come over here to 6. I'm going to say 6 is right here. So it's 6. It's at the value of 1. So it's going to be in here somewhere. So this function is going to be coming up, and it will not touch the y-axis, and it's going to be going like this. Okay, so this has a vertical asymptote at x equals 0, which is the y-axis. It's not going to touch that. The x-intercept is going to be 1. X equals 1. Or if you want to put it as an ordered pair, 1, 0. This ordered pair right here. Okay. This does not have a horizontal asymptote. Oh, I didn't ask for that. All right. Logarithm. Okay. Sketch the graph. We did it. Domain. We've not done the domain. Well, it does not touch the y-axis. So you have a parenthesis 0 for x, and it goes right forever. So the domain will be 0 to infinity. And that's that problem. Now these problems right here, we're going to use this, that ln and e are inverse operations. And I'm going to do number 50 here, which says we want to change the natural log of 7 equals 1.945 ... into exponential form, which means we have to change it to e. So what we want to do is we're going to take and we're going to make e raised to that power, and over here e raised to that power. This e and ln cancel each other out. So this is just 7, and this is e raised to the 1.945 power. This is the exponential form for Euler's number. That's our answer. If I do number 52, we're going to do it very similarly. 52 says the natural log of 1 equals 0. So we're going to do an E here, and we're going to do an E here. And this cancels out, so I get 1 here is equal to E to the 0. And like I just said a few minutes ago, anything to the 0 power is 1. So that's that problem. Now I'm going to do this problem using the inverse again. So 54 says E to the negative, I'm going to get some space there. E to the negative 3/4 power is going to equal 0.4723. So the inverse of E is a natural log. So I'm going to do natural log of this. I'm going to do natural log of this over here. So E and natural log cancel each other out, and I get negative 3/4. And over here is equal to the natural log of 0.4723. That is the natural log form of E. If you do the same thing here, you natural log this side and natural log this side. This E and natural log cancel out, so 2x is going to equal the natural log of 3. And we're done. So this is what you're doing for homework. You got the odds. Hope you have a great day, and I will see you in class next time.